This is the best use of digamma function. Yeah. So this is basically a double integral. Yeah. And the first thing you can notice is that integral is going from 0 to 1, 0 to 1. Yeah. And over here we have 1 minus r. So basically, if we take this in the numerator, we will have a by 1 minus r form. And so you can use infinite geometric series formula and then introduce a sum and then simplify this integral and extend sum and integral, and we can solve it that way. Yeah. So let's begin. We have integral from 0 to 1, integral from 0 to 1 of root x plus root y, and then we will have xy to the power minus 1 by 4. Yeah, by 1 minus xy, and then dx dy. Now this can be written as a sum, as an infinite sum. Integral from 0 to 1, integral from 0 to 1, root x plus root y, and the infinite sum where let's say I goes from 0 to infinity. First term will be xy to the power minus 1 by 4, and then ratio will be xy. So it's a by 1 minus r, yeah? xy, and then to the power I, this is the common ratio, and dx dy. Now we can interchange this. Since sum is in the world of I, root x plus root y can be taken inside the sum, and then sum and integral can be interchanged. Sum from I equals to 0 to infinity, integral from 0 to 1, integral from 0 to 1, and then over here uh, we will have x to the power 1 by 4, y to the power I minus 1 by 4. Yeah, and then plus over here y to the power 1 by 4. Yeah, is that okay? So I don't think that is. I don't think. Also, here also it should be I plus 1 by 4. Yeah, if you multiply first of all by root x to this term, we'll have I plus 1 by 4. Yeah, and then y to the power 1 by 4 plus I, and then x to the power I minus 1 by 4. Okay, so that is the case. And then dx dy. Now we can use the plus sign to separate these integrals. Sum from I equals to 0 to infinity, integral from 0 to 1, integral from 0 to 1. So first of all this integral I plus 1 by 4, y to the power I minus 1 by 4, dx dy, plus the integral from 0 to 1, integral from 0 to 1, x to the power I minus 1 by 4, y to the power I plus 1 by 4, dx dy. So now you can notice that these two integrals are actually the same. If you just interchange x and y, yeah, those two are gonna be the same. So that's basically just the dummy variables x and y. So it doesn't matter. So that's why we can write it as sum from I equals to 0 to infinity 2 times integral from 0 to 1, integral from 0 to 1 of x to the power I plus 1 by 4, y to the power I minus 1 by 4, dx dy. Now we can just integrate this alone. Yeah, basically because we have integral from a to b, integral from c to d of f of x, g of x, dx dy. If we have such f of x, g of y, dx dy, then we can just integrate like them part by part and then find the product. Integral of f of x dx times integral of g of y dy. Yeah, we can do this. Yeah. So due to that, we can also do a similar procedure here. Sum from I equals to 0 to infinity. Yeah. And then integral from 0 to 1 of x to the power I plus 1 by 4 dx times Integral from 0 to 1 of y to the power I minus 1 by 4 dy. And next, let me first increase the size of screen. Okay, now next is this is the easy integration, sum from I equals to 0 to infinity. That will be x to the power I plus 5 by 4 by I plus 5 by 4 from 0 to 1 times y to the power I plus 3 by 4 by I plus 3 by 4 from 0 to 1. And this is 2 times sum from I equals to 0 to infinity. This will be 1. Okay, so at 1 x equals to 1, so that means 1 by I plus 5 by 4. At 0 this will be 0, okay, it doesn't matter, times this will be 1 by I plus 3 by 4. Okay, fine. Now this is the sum that we have. Now we can use partial fractions. We can basically introduce that I plus 5 by 4 minus I plus 3 by 4 numerator. Yeah, and that is the difference will just be 2 by 4, that's 1 by 2. So introduce a 1 by 2 in the denominator as well. So that is 4 times sum from I equals to 0 to infinity. This will be 1 by I plus 3 by 4 minus 1 by I plus 5 by 4. Okay, now you need to know a property of digamma function, that if sum is going from 0 to infinity, yeah, and it is 1 by I plus a minus 1 by I plus b, then this is just digamma of b minus digamma of a. So we will use that property now. Yeah, okay, so if we use that property in this sum, we will have 4 times digamma of 5 by 4 minus digamma of 3 by 4. Now we should also know that digamma of a plus 1 is equals to digamma of a plus 1 by a. So if we use that, we will have this will be digamma of 1 by 4 plus 1 by 1 by 4 minus digamma of 3 by 4. Yeah, and now this will be 4 plus digamma 1 by 4 minus digamma 3 by 4. Okay, now let me increase the screen again. Now we are at around the end of this problem. Now we need to know the reflection formula of digamma. The digamma of 1 minus x minus digamma of x equals to pi by 10 pi x. So over here we basically have 4 plus, this is digamma of 1 minus 3 by 4 minus digamma of 3 by 4. So I can use the property now, the reflection property, that gives us 4 times 4 plus, that will be pi by 10 pi times 3 by 4. Yeah, now 10 of 3 pi by 4 is minus 1, so 4 times 4 plus pi by minus 1, and that gives us 16 minus 4 pi as the answer. 16 minus 4 pi, so the answer is 16 minus 4 pi. And the main idea that involved in this problem is basically changing this into a geometric series. Yeah, after we did that, the other things were just pretty straightforward. Yeah, so that was the only tricky part. Others were just pretty straightforward. I hope you enjoyed this tall integral. Thanks for watching. Look forward to seeing you in the next videos.